Look closely at the world around you right now. I mean, really look at it. What if the crisp, high-definition detail of our reality is actually just a high-resolution render? Welcome to This Explainer. Today, we're diving straight into a cosmic detective story. We're going to treat the universe like a piece of software, and we are hunting for the digital glitches that suggest your entire life is actually a highly sophisticated calculation. From the incredibly bizarre behavior of quantum particles to the rigid mathematical limits of our universe, the fundamental pixels of our existence are really starting to show themselves. Seriously, look at your hands. If you firmly believe your physical body is made of solid, absolute matter, well, the latest mathematical paradoxes and quantum anomalies are about to completely flip that idea on its head. Scientists are uncovering actual inconsistencies in the fabric of space-time that strongly suggest we inhabit a programmed synthetic construct. So we have to ask, is the reality you experience absolute, or is something like entropy just a deliberate piece of code designed to keep us trapped in a simulation? Okay, to get our heads around this, let's start with a brilliant concept from the legendary theoretical physicist John Archibald Wheeler. He coined this famous it from bit doctrine. Wheeler pointed out that reality's fundamental building blocks might not actually be physical stuff at all. Instead, every particle, every fundamental force, even the space-time continuum itself, might derive its entire existence from binary choices. Bits, just pure information. The implication here is absolutely staggering. What if the universe isn't a machine made of matter, but a computer made of information? Let's explore that in Section 1, the universe's pixel resolution. To really grasp this hardware limit, we need to zoom in far enough to see the actual pixels of our reality. Now, if you think about classical continuous math, space can be divided infinitely, right? You can always take a physical distance and just cut it in half, forever. But in a physical system, that leads to logical crashes. Take Zeno's paradox, for example, where motion becomes technically impossible because you're endlessly crossing infinite half distances. Well, discrete physics argues that our universe has a hard-coded limit to resolve these mathematical errors. Just like your computer screen literally cannot display half a pixel, the universe cannot render infinite divisions. And amazingly, we actually know the exact size of that cosmic pixel. It's this incredibly tiny number, 1.616 times 10 to the power of -35 meters. In physics, this is known as the Planck length. Think of it as the absolute minimum spatial resolution of our rendered environment. Below this size, the very concepts of space and distance completely break down. They cease to exist. The universe essentially uses this pixel size as a hard cutoff to prevent the infinite physical regressions that would otherwise crash our cosmic computer. And pure mathematical logic proves why this sort of quantization is absolutely crucial. It comes down to something called the Banach-Tarski paradox. See, in continuous mathematics, you can take one solid sphere, mathematically cut it into very specific pieces, and reassemble it into two identical spheres of the exact same size. It is literally a cloning cheat code. But it requires infinite mathematical precision. Physical reality completely blocks this exploit by running on discrete, finite units. The conservation of mass and energy prevents infinite volume multiplication, meaning our reality practically has to run on a finite quantized grid just to prevent massive system exploits. Which brings us nicely to Section 2, quantum lazy evaluation. Moving down into the subatomic realm, we find an incredible processing shortcut that the universe seems to use. In computer science, there's a brilliant optimization strategy called lazy evaluation. Basically, a system defers computing a variable until it is absolutely required by an active process. If you play modern video games, you've definitely experienced this as occlusion culling. The game engine only renders the graphics that your character is actively looking at to save on memory. Well, in quantum physics, this is exactly what appears to happen during wave function collapse. The delayed choice quantum eraser experiment illustrates this perfectly in action. Initially, a particle remains as an unrendered wave of probabilities as it passes through an experiment without an observer. But the exact moment we query it with a measurement, we force a definitive collapse into a single physical state. But here is the massive glitch. If researchers erase that measurement data after the fact, the particle actually retroactively restores its wave pattern. It literally rewrites its history to maintain logical consistency. Particles just remain as unrendered background threads until a measurement explicitly queries them. And this isn't just a wild theory. A breakthrough experiment by Australian scientists proved that what happens to particles in the past is only decided when they are observed and measured in the future.
So the crucial takeaway here is that our past physical history is not a static, permanently written database. Not at all. It's a dynamically resolved ledger that actively waits for an observer to force a render. Reality, until it is measured, is quite literally just an abstraction of code. Let's shift gears to Section 3, Cosmic Data Compression. Think about this. If the universe is rendering data on demand, its hardware must have incredibly strict memory limits. This massive number on screen, a 10 with 120 zeros after it, represents the estimated bits per second the universe processes just within our observable volume. Imagine the sheer processing power required to render every single atom, every photon, and every complex interaction. A computational system that large demands incredibly aggressive efficiency algorithms just to keep from melting down. For context, that kind of processing power makes your high-end gaming PC look like a wooden abacus. Enter the Bekenstein bound. This principle defines the absolute maximum amount of information that can possibly be stored within any given volume of space. And fascinatingly, it scales exactly with the volume's surface area, not its 3D volume. When you look at it this way, you can start to think of the second law of thermodynamics and entropy itself as a cosmic data management system. Entropy acts to restrict the universe's total available information, preventing a catastrophic accumulation of infinite data that would otherwise overload the whole system. And the ultimate proof of this data limit is found in black holes. Black hole event horizons exactly saturate the Bekenstein bound, meaning they represent the absolute densest physical storage format possible in nature. Because black holes maximize this data limit based on their 2D surface area rather than their 3D volume, scientists propose the holographic principle. This is the mind-bending suggestion that our entire 3D universe might just be a projection, a 3D spatial render generated entirely from data stored on a flat, 2D informational hard drive at the outer boundary of our universe.
So, what do we do with that? Section 4, Hacking the Universal Code.
If space is actually just a compressed holographic projection, the next logical question is, can we find exploits to hack the system? If physics is fundamentally just software, it's wild how perfectly physical laws map onto standard software engineering principles. Look at this. Wave function collapse? That's lazy evaluation. The Planck length? Literally just screen resolution. Decoherence and entropy function exactly like routine garbage collection for unobserved states, constantly clearing out the memory cache. And quantum entanglement? That acts identically to memory compression using pointers, where the universe stores one state and uses a pointer to reference it from two entirely different locations just to save memory.
Once you start viewing physics through this computational lens, you can actually look for real system exploits. For example, by executing what physicists call weak measurements, researchers theorize we might be able to extract partial data without triggering a full wave collapse. By breaking underlying symmetries, we might completely bypass conservation laws. Or we can leverage the quantum Zeno effect, where continuously observing a quantum system literally freezes its state evolution. It's exactly like pausing a background process on your computer. In this framework, conscious observation isn't just some accidental byproduct of biology. It is a direct API interface with the universe's foundational substrate. Finally, let's wrap up with Section 5, Finding the Master Programmers. If we are genuinely finding system exploits, rendering shortcuts, and hard-coded pixel limits out there in the cosmos, we have to ask the big one: who or what is actually running this simulation? The philosopher Nick Bostrom formalized this exact problem with Bostrom's trilemma. It mathematically demonstrates that one of three things must be true. Option 1, humanity goes extinct before ever becoming highly advanced. Option 2, advanced civilizations have absolutely zero interest in running ancestor simulations. Or Option 3, we are almost certainly, right now, living within a simulated reality. Bostrom's logic shows that if an advanced civilization ever achieves the computing power to run conscious simulations, they wouldn't run just one, they would run billions. Statistically, that makes our odds of being the one true base reality practically zero. So I want to leave you with this final provocative thought. If everything, from the Planck-length pixels of space, to the thermodynamic memory management of black holes, to the lazy rendering of quantum particles, points to a synthetic reality, does it actually matter? Whether you are made of solid physical matter, or you are just elegant lines of code successfully resolving mathematical paradoxes within a giant cosmic engine, does it change the profound mystery, the deep emotion, and the meaning of the reality you experience every single day? It is definitely a question worth processing. Thanks for joining me on this explainer. Keep questioning the code around you.